Okay, friends, welcome to my YouTube channel. And today we are going to understand what is this floating production storage and offloading, which is properly known as FPSO. So, FPSO is a gas processing or oil processing plant which is on the ships actually. So, how they look like? So, I have a quick image. You can see that these images are there for the FPSO. This is a ship, and the whole structure, the upper deck is we call it top side, which is all the processing units are there actually, and the whole is which is down, which has utility system and other system which is getting connected to the ship actually to run this topside process plants. These are the process plants actually, mostly um, gas type actually, mostly gas processing, and sometimes there's a liquid processing as well. And this is something like not on the ship actually, it is on the proper structure on the seabed actually. So so today we're going to discuss some key points on FPSO and how it is how the process engineers can look into these aspects of designing and subsequently design their FPSO plant actually. So introduction is that floating production storage and floating unit is a boat or better a floating vessel part of offshore area with the main goal to recover process the hydrocarbons from subsea reservoirs and to provide the storage facility. The FPSO are flexible, easy to install, and not required a pipeline to unload the crude oil. FPSO are used for small oil fields in deep water and for the remote location where the subsea pipelines are not a cost-wise solution. So you can see there's a block flow diagram also. What is the block flow diagram? It says that it is a field which is a target, means like mostly where the flow lines are there, then HP separators are there. So this is from HP separator it becomes a processing unit actually. HP MP separator, dehydration or desalters, and then you can see the salt waters is connected through desalters and dehydration unit, then LP separator and gas compressors and the gas, and you can see this two trains of gas and oil actually. So this is overall uh, process flow diagram for the FPSO. Okay, and let's look into other thing that what is the major process description for the for this one for FPSO. So the crude oil, gas, and water are produced manifold is feeding SP separated at 24 bar gauge fixed by the choke wall operation temperature as 42 degrees C. This is typical values I am talking about actually, and then accordingly it gives you it can the pressure and temperature can vary. The crude oil is sent under flow control reset by HP separator level control to the medium pressure separator. MP separator is operating at 4.5 bar gauge. The separated oil is pumped with the crude oil pump to the dehydration unit to remove water, which operates full of liquid at 9.5 bar gauge via the crude oil heater or mixing valve. Upstream mixing valve, the oil is mixed with water to enhance salt removal. So basically, the crude oil has inhaled salt in the form of NaCl and BSNW, and to get on spec um, crude oil, the RVP and BSNW are maintained. BSNW, this desalters and all, they help to get rid of salt and the water content in the oil actually. And there is a spec actually. You have to find it in the Saudi Aramco standards. What is the crude oil specs after of the desalters? 0.5 ppb the salt content, and RVP of close to I think 10 psi or something like that. Okay. The crude oil from the dehydrator is mixed with wash water and sent to the desalter, which operates as 8 bar gauge. From the desalter, the hydrocarbon phase under the process pressure control is feeding the low pressure separator, where it is stabilized and sent to storage tank via the crude oil cooler. So the RVP is maintained in LP separator. So gas from the LP separator is recovered by the LP gas compressor and compressed from 0.07 to 4 bar gauge. So we saw that BFD. You can see that So further flashing of the so from the oil stream, further flashing of the gas happens when the pressure is lowered, and from there it's almost zero point 0.7 bar gauge here, and from there it goes to the compressor and sent to the export line of the gas. So The LP separator recovered by the LP gas compressor and compressed gas from 0.7 to 4 bar gauge, mixed with gases from MP separator, cooled down to MP compressor suction cooler, and compressed to 17 bar gauge using LP gas compressor. There are series of compressor which increase the pressure of the gas. Okay, the MP gas compressor gases uh, the MP gas compressor gases are mixed with HP separator gases and sent to HP for stage suction scrubber, cooler and cool down. The gas are compressed from 16 to 300 bar in stage of 3 HP gas compressor. Okay, so basically this talks about how the pressure subsequently are increased in the gas line to for the dew pointing and for any case in acid gas is there, then it is removed accordingly. So the gases from the first stage HP compressor are sent to the TEG unit and then to the second stage HP. The TEG unit is basically removing water from the gases and meeting the water dew point in the export gas. Hope this is clear. Basically, we are talking about some key points at how the oil and the gas are produced or are processed actually. Then simulation tips and tricks actually that thermo package despite available process simulator in the market, the recommended general thermo package is Peng Robinson with key cluster for enthalpy and for HYSYS, Petrosim, Unisim, SRK Simsai with Lee Kessler and for enthalpy Pro 2 and for Pro Max SRK Peng Robinson. So Peng Robinson is something which we all use in HYSYS and this is a recommended package for a simulation. An important thing is to remember that to supply the pseudo components properties, the binary interaction parameters, and if available. So pseudo components, in case the client gives you the pseudo complex, you have to simulate the pseudo components in the simulation. It's necessary to estimate the properties of the what it says. One sec. It is necessary to estimate the properties of pseudo components. The following shall be considered. Suppose pseudo components are something which is not a crude defined true components, which can be the higher components, which is like you can simulate into in HYSYS actually, and there is a like components which is pseudo components in the HYSYS, and we can simulate that. It's saying some information about the pseudo component like gas condensate system. SRK API is better than PR at higher pressure. For enthalpy, Lee Kessler, entropy SRK, and heat capacity. This talks about different process packaging actually when you're trying to develop the pseudo component oil and gas system SRK, oil system SRK, supercritical SRK API. If water is not present, it is not condensing. Use the same correlation and set model of vapor and liquid phase. To estimate viscosity of liquid vapor phase, use ELI and Slade NBS model for the supercritical system and Peterson corresponding state method for remaining system. The identical TBU API correlation are not taken into account. Effect of dissolved critical components and ideal is situation for system with operating pressure of 29 bar gauge. We're talking about some Great G 2008 property package, but I think more seriously the version 4.14 of API we are using Peng Robinson even if for the pseudo components. Okay. Then it talks about methanol assessment use CPA from HYSYS. Then considering level, remember that most important step is tuning the pseudo components properties to match. So basically we have to match our pseudo components properties so that overall molecular weight of the inlet feed is in the proper range actually. Saturation pressure is by temperature. GOR measured in PVT, crude oil density and viscosity in PVT or laboratory test. Simulation layout. Feed composition of feed 1 are as per the table. You can see these are some of the components and these are the field 1, field 2 composition actually. You can see and it is up to and decane, water is also there and step by step simulation. Say what are the key things like check the properties of each field of production at pressure temperature of the well, take a new stream and set a composition of the well. TNP, adjust GOR and water component as per production profile, use simple calculation block to set oil and gas production and water, pay attention to unit of measurement, Set the normal condition as per project specification, like 1 bar and 15 degrees C. This is the standard conditions. Remove water from indicated well composition for oil and gas stream to close heat and man for heat and man. So basically, it's talking that in HYSYS we can create components, and mostly pen convention should be done. You can specify the standard condition at 1 bar and 15 degrees C, and then GOR is adjusted through setting up set and oil block and to set an oil and gas production profile. GOR is gas to oil ratio, and this is quite critical when we simulate the inlet feed actually. Okay, then combine the gas, oil, and water stream to obtain the corrected composition based on production profile as per figure 1.2. So basically you can see production profile is X, oil, gas, water is there. Gas you can see, then filled and water is added. Actually see the mixture is created, and from there you can see that we have created separators and water removal block is there, water, and then adjusted stream actually. So basically this block is setting up the GOR, and finally we are getting the adjusted stream conditions, that what can be the ideal feed condition from the wells. Okay, hope this is clear. So see the production profile is changing it actually, adjuster is applied and accordingly the ratio is filled. Is okay, so hope this diagram is clear about whatever how to get the exact feed. The layout presented below is neutral and can be implemented in any available simulator. Then this is the simulation layout. You can see this series of HP, MP, LP separators, series of compressors to compress the gas. So this is how they look like. Some key points about the pressure. What is the pressure? So this is typical ones. It can vary from project to project, and accordingly we can see how the behavior of fluid is there uh, in the feed, and how the production is set up actually. HP separator 19, NP 4.5, LP 0.7, dehydrator 9.5, desalters. So these dehydrators and desalter on the oil lines, and these are the two. They can be two or three phase separator, and the bottom one MP and LP can be two phase separators. Actually, most of the liquid and water is removed from the HP separator. This typical pressure drop substance, like if there's a crude hot heater, cold and hot side, 1 bar pressure drop. So basically these pressure drops are used for the simulation case, like how we determine the pressure drops in the equipments, and accordingly you can determine your simulation and pressure profile across from the suction to the discharge, and accordingly compressor duties are set, compressor powers are set, and accordingly you can do a simulation. Take unit zero point 0.1 to zero point 0.5 to 1 bar, export hot to zero point 0.7, LP suction, compressor suction 0.3, HPLP LP 0.03, pressure drops basically, choke valve 5 bar, and then control valve liquid side service 0.0, 0.5 bar. Typical pressure drops as shown here. More on the control valve in the gas service, 20% of circuit pressure drop or 0.5 bar, which is higher. Orifice plates pressure drops are there. You can see compressor and pump efficiencies. You can put into HYSYS simulation file. Pump efficiencies are there. Then compressor and cooler exist to temperatures set in simulation up to this pressure. Hope this is quite clear. Then discharge temperatures of the coolers, then separated carryovers. This need to be also added into the simulation files. It talks about 5%, 0.5%, 0.2, which is carryover gas of liquid in the gas system, gas phase. Now some of the design recommendation is that first separator shall be sized through the normal size procedure, but in accordance to liquid surge from production line between high and low liquid level, in addition to 5 minutes hold up or 0.5 meter, which is indicator. This talks about what is the surge minutes should be there for the first separator, or you can say HP separator. Uh, and then it talks about level settings, and so one thing is that now there is a slug volume should be added also between low and high liquid level, so that In case of picking operation, whatever the surge, extra surge is coming is adjusted in the separator, first stage separator. Then again it talks about the height between each level shall be higher than multiplied with the vessel diameter for the vertical pressure or length of oscillation divided by 2. Some of the fundamentals, and you can see the salt content in the oil 15 ppb. I talked about what is the salt content when it comes out, when the oil comes out from the desalter. Again more on the high liquid and distance between high low low vessel bottoms. Typical values are given. Space between high and top vessel minus contingency of the wave shall be checked against the maximum vapor velocity. You can see this is some of the separator sizing criteria. Again, it says that control level instrument should be installed as close as possible to the center of the vessel, and perforated vertical baffle should be installed along the vessel. This is the separator liquid level perpendicular to the axis of the drum in way that the net area should be in the range of 22 to 25 to 50%. The higher liquid level instrument should be located close to the protected device. So it talks about possible higher close to the possible to wear. Low interface level should be possible to high phase outlet. Low close to possible to light phase outlet. So it talks about how you can see this is a kind of three-phase separator. We can see this water is there in the blue, and there's a baffle is there, and then oil overflows the baffle and comes out. So this gives a typical criteria about interface levels of interface level plus oil and water level actually. So this comes under three-phase separator criteria. We will discuss more on our separate when I produce a separate video on three-phase vessels actually. Then we'll go in more elaboration on that one. Then this is a inlet nozzle sizing design criteria which talks about momentum, rho v square, and this is like in case you have got inlet devices, no inlet devices there, 1000 submerged inlet, 1000 inlet divider, half open. You can see this table, and you can stop my video and you can see these tables, rho v squared for the nozzle sizing. Similarly, the outlet nozzle shall be sized in the way that rho v squared should not be greater than 600,000 PA momentum, because it should not create stress in the nozzle, and stress related fatigue should not be in the pipes on the nozzles. Okay. So it's very clear about the nozzles on the vessel. That desalter operating temperature shall be set considering the density and viscosity of the crude oil in a way to minimize consumption of washing water, which is obtained through the reverse osmosis. If the crude oil is heavy with API less than 20, so water to API is 10, so it is less than 20 is close to water actually. And the mixing valve delta P shall be increased to 2.5 to 3 bar because it is more viscous. The crude oil with viscosity between 4 to 10 centipoise, the desalter retention time should be minimum 20 minutes, slow desalter, and for viscosity lower than 4 cp, the fast desalter shall be used with 10 to 12 minutes of retention time. So see, when the viscosity is lower, this means that you can the detention time can be reduced actually, because high viscosity means high residence time in the desalter. What are the key takeaways? Like lab analysis is very important step for proper construction of the crude oil properties and shall be used for as much as possible. The pseudo component product shall be tuned to match the lab analysis. This is for HYSIS. Pay attention to crude oil viscosity and density in order to proper set and optimize the desalter operation, because desalter are critical for meeting the spec of the crude oil. To calculate the viscosity of crude oil, use refrigerants at the same temperature. I think this is a viscosity chart which nowadays is available through lab. Remember that FPSO are in continuous slow motion and the top side equipments are affected. Introduce margin in the design to account for this aspect and check the separate design using the CFD analysis. Like they are saying that okay, three ways separators are there. Use CFD to see that there is a separation efficiency are met actually. Okay, so they are saying that in the case of crude oil, na, use packed ones, don't use trays. And what else? The first separate design should be slug flow. The first separate stage design should account for slug flow, which I told you, like 50 to 100 meter cube. Mostly, it should be the slug volume inside the separator. And look for oil properties, density, viscosity, and cloud point. Assuming the pressure in the flux is fixed in the first stage separator, and also in the last stage, the storage. For storage stage, optimization of operating condition is must because it's only real item in the FPSO where you can change the operating condition. Look at various cruise viscosity because impacting the design. So it's talking that when you design the things, you see the full range of viscosity of the crude oil actually. Okay. Um, Now, for the desaltation, it is saying that desalination stage, pay attention to crude viscosity and density. They will set the operating temperature. The salts in the crude are 10 to 20 ppb. Oil in the water is 50 to 80 ppm weight. Water in the oil is 0.2 0. Volume percent. So this one talks about like how this oil and the water and the salt content in the crude varies actually. Optimize the desalter operation condition and mixing the valve of pressure drop to minimize wash water consumption because wash water are created through reverse osmosis. They are very expensive. So the idea is to reduce the wash water consumption. Okay. Proper size of equipment downstream separate is recommended. Uh, that the carryover is to be considered in the design. Separator is not 100% efficient, so it's saying that okay, we consider this some carryover accordingly. So it talks about separator efficiency of the flare of KO drums actually 90 to 95%, 10 to 30%. So as long as you provide wind packs, demister, no demister, so accordingly the macron size and the efficiency decreases. And similarly, this is also three-phase separator, liquid max 95% to 280 to 300 microns actually. So this talks about different uh, droplet size and the efficiency of the three-phase, two-phase separators. Okay, so this is all about the FPSO. This no, I know it's not in detail because I'm not intending to create a very long video because people lose interest when I produce long videos. So hope you like my channel and hope you like this presentation. Do tune in for more such videos, and I will start putting more as soon as I like more topics are available to discuss.